Hello, everyone, and welcome to today's webinar, Transform Vulnerability Management with AI. I'm your host, Mike Teeling, and we're very glad that you can join us. Security vulnerabilities have evolved from an occasional risk into a daily operational burden. Engineering and security teams are now struggling with a flood of common vulnerabilities and exposures, also known as CVEs, as well as alert fatigue and manual remediation processes. All these challenges slow development and divert attention away from innovation. The reality is this: detection alone is no longer enough. Traditional vulnerability management tools generate too much noise with not enough context, leaving teams overwhelmed rather than empowered. That's why today's conversation is so important. Joining us are two experts from Talentica Software. Please allow me to introduce Aniket Shaligram. Aniket is Vice President of Technology for Talentica and has over 20 years of experience designing secure, scalable, and resilient systems across industries. We also have Hemant Sachdeva. Hemant is a solution architect specializing in secure enterprise architectures, cloud platforms, and modern engineering practices. Hey guys, welcome and thanks a lot for being with us today.
Hi Mike, hi everyone.
Hi everyone.
So together, we're going to explore how AI is transforming vulnerability management. Our discussion will range from intelligent CVE analysis to guided code migrations. We'll talk about automated refactoring all the way to validation. So over the next 45 minutes, let's show the agenda. Oh, can we get the agenda, please? Great, thank you. Over the next 45 minutes, here's what we'll talk about. We'll talk about the modern CVE challenge and why it's straining engineering teams, why traditional tools fall short, how AI enables smarter, faster, and more secure remediation, and a real-world example using an AI approach. And of course, we'll answer your questions. Before we get started, there are a few housekeeping items that I want to cover, okay? So during the session, you'll see a couple of pop-up polls. Your participation is optional, but would love your input. So please respond and lend your opinion to our topic. Be sure to stick around until the end, because we'll also have a live Q&A where you can ask your own question of our AI experts. Finally, today's webcast will be made available through an on-demand playback link that will be sent to your registration email right after today's session. All right, so with that out of the way, let's dive right in. Aniket, can you take it away?
Thanks, Mike. Good morning, good afternoon, or good evening, depending on where you are joining us from. To build on to what Mike said, I'm a VP at Talentica. I oversee product engineering across multiple products and technology stacks, which means I routinely see firsthand how vulnerabilities surface, how they slow down the teams, and how they impact delivery timelines. So today, my goal is simple. I would like to give you a pragmatic, AI-enabled process for handling vulnerability management, something that you can take back to your teams. So let's dive in. So one of the clear trends we are observing in vulnerability management is steadily more developers are spending more time than ever fixing vulnerabilities. So in the last year alone, what we have seen is that open source libraries have increased vulnerabilities by almost 20%. When we categorize these different types of vulnerabilities and map the engineering effort spent on each category, we see roughly 75% of the total remediation effort sits with the application developers. In the chart here, right, what I have seen is 15% is spent in fixing application level vulnerabilities. For example, SQL injection, cross-site scripting. 60% is spent in upgrading libraries. So when I talk about upgrading libraries, it is typically a version bump fix. A vulnerability appears, say, in a common IO 2.4, it resolved in 2.5, and engineers need to upgrade. When they do this, multiple CVs often get fixed. To make this a bit more concrete, let me walk you through a few projects that we have taken in the last 18 months or so. So the first project was a edtech startup, wherein an vulnerability in Solar with a misconfigured security group led to data theft. So it was a staging setup. So the data was synthetic, but that did trigger hardening activities on non-prod environments. In the second project, we had a product with high and critical CVs that were not getting resolved at agreed SLAs. And so the renewals were threatened. In the third project, the team had ignored non-critical CVs for a long time. And the backlog had grown to what? Almost 2000 CVs. When a prospect finally refused to buy the product unless the CVs count came down, this project was initiated. So we'll talk about this project a bit more as we go along. But if we look at the remediation effort that was involved, the first scenario took almost what, 2% weeks? The second one took almost 2 months. And the third one, I think it was the most complex and it took 20% months. So point here is that most of the time the team spent time in fixing CVs by upgrading third-party libraries. So now as an engineer leader, we like to track numbers, right? And in the vulnerability space, there are a couple of them. The first one is mean time to remediate for critical CVs. And the second one is the number of age CVs, essentially CVs that are what, 90 days old. Most orgs focus heavily on the critical CVs, right? And rightfully so. But what we have learned is the non-critical CVs can't be ignored either. If they sit in the backlog for more than few months, the attack surface grows, and then the upgrade path, right, from say 2.5 to 3.2, right, it becomes harder. With the rising number of CVs, this aging backlog is growing faster than most team can handle. As we saw in the last example, both critical CVs and age CVs impact business. So from a remediation perspective, the mandate becomes clear. How do we reduce the engineering effort needed to stay within these KPIs? For us, this naturally led to the next question, right? Can AI meaningfully assist? So there are two questions here. Can AI help automate or accelerate dependency upgrades so age CV don't accumulate? And can AI reduce the time it takes to manually fix a critical CV? So now let me walk you through a key project that really pushed us towards adopting AI for vulnerability management. So everything we'll discuss today, the techniques, the patterns, comes directly from this real-world implementation. The project that came to us was after a failed attempt by a partner team. They had I think they tried to fix all the vulnerabilities manually and had estimated around 72 man-months to remediate roughly 2000 CVs. So they staffed a 12 people team committing to deliver all of that in 6 months. But only after 2 months, there was any progress. And so we were brought in. Now, when my team was brought in, what we looked at was there were various challenges. Like they were fixing CVs purely based on priority labels with no smarter prioritization or batching strategy. There was a significant duplication of effort, multiple team members solving the same issues independently. And when they did ramp up the team, there was confusion around what kind of talent do they need. Do we need security specialists? Do we need product engineers? So then, so on top of that, yeah, so there was another issue about how do we manage framework, library, and language upgrades. So we stepped back, thought about the problem from grounds up, this time exploring if AI can help us in remediating the effort faster. And whatever Hemant will walk us through is all based on the experience that we gained through executing this project. Essentially, we were able to fix the 2000 CVs in what, almost 10 man-months. So yeah, what do you, Mike?
Thanks a lot, Aniket. That was awesome. That great example. So everyone, it's time for our first poll question. So please take a moment to so we can understand where the audience stands with your approach to vulnerability management. So the question is, what's your biggest challenge with vulnerability management today? The choices we have here are there's too many alerts or alert fatigue. Next is slow remediation cycles. Third, a lack of prioritization and context. Then a manual code refactoring effort. Takes a lot of time there. Or all of the above. So take a moment, please, to respond and record your responses here. And we will share the answers to these poll questions when we follow up with you after this session. Great. That's good. Thank you very much for your response. Your response gives us really good insight into the real challenges that organizations like yours are facing. So now, let's continue exploring how AI is changing vulnerability management. Hemant, over to you.
Thanks, Mike. Hello, everyone. Welcome to the session. So, as Aniket has explained us, that fixing CV takes most of the time, right? So during my talk, we will look at why this is the case, why it takes a lot of time, and how we can solve it using AI, right? So let's look at the traditional way where there is no AI and there is no automation, all right? So it starts with a process called scan. So we'll scan our application to know if there is any vulnerability in our application or not, right? So when we run a scan, we'll come to know there are so many CVs or not, right? So then there is a step called fix, and this fix step is a problematic one because as of now, developer or say security engineer try to fix the CVs using a manual approach, right? So they will manually search the internet to understand how to fix the CV, and they manually try to fix it. They manually try to code it. If there is an error while fixing the CV, then they follow same loop again, right? So I'll call it as a hit and trial loop, right? As you can see, it takes a lot of time to fix the CV, but eventually, after a lot of effort, it will get fixed and it is ready to be reviewed by a person, right? So this is the traditional way. Obviously, it takes a lot of time, but is there a better way to fix the CV? So yes, there is a better way if we use AI and have a streamlined automation process in place, then we can fix it smartly. So the first step where we scan, the application will remain the same. We have to understand whether the application has any CVs or not. So the next stages, which were the fix stage, we will fix that fix stage. So now we will have a more streamlined processes. I'll talk about these processes in detail in my upcoming slides. But at very high level, I will just talk about, I will show you all these steps, right? So now the fix step converted into multiple steps. The first step is AI analyze, then AI migration guide, then AI assisted fix, and the final one is same like peer review and human review. So what is scan? So I'll talk about scan process. If you look at the image at the right hand side, so there are security scanner tools, right? So these are the tool which is readily available in the market, both as open source as well as commercial one. In the example, I have shown like Privy, Sneak. So these are the open source tool. These are the security scanner tool. So we are supposed to run these tool on our application. So application, as you know, consists of primarily two parts. One is application code, then other one is dependency, right? Our application depends upon third-party libraries. So when we run these security scanner tool, it will give us a report, right? As you can see in the image at the right-hand side, bottom side. So it will give you report. So in the report, it will highlight what all libraries are infected with CVs. If you look at the report, so there are certain boxes which are highlighted as a red. So which is showing that these libraries are infected one, right? They have certain CVs, and it also tell you how many CVs are there, right? So as in this example, it is showing a particular, say, common IO library has these many CVs, and it also tell you how you can fix it, right? It give you multiple option. Like if you upgrade to one of these available option, your CV will get fixed, right? So at the end, developer has to upgrade the library from one version to another version. Even though it sounds very easy, but why this is a problematic? Why it is difficult to keep application CV free? So this is because, so whenever we upgrade a library, it require a application code changes, right? So depending upon the type of library upgradation, say if we are upgrading to a major version upgradation, it require a major change in our application code. Similarly, say if this is a patch version upgrade, it require a less number of changes in our application code, right? So that's where the problem appears. So now I will talk about analyze part. So I will talk about what problem analyze step will try to solve. So there are so many problems, but I will just explain top two problems. So as you have already seen the report, in the report, a report gives you a multiple version option, right? To which a library can upgrade to. Like in this diagram, I have fetched one library, and for one library, as you can see, it is giving us multiple CVs. If you look at the second column, so it is saying for this library there are 4 CVs, right? And how can you fix those CV is by upgrading to these many versions. If you look at the fixed version, there are multiple version options, right? So which version to pick, this become a problematic, right? Developer don't know on which parameter, right? On which criteria he will choose which version, right? So this is the first problem, like which version to pick. Then the second problem, so when we ran security scanner tool, right, it will highlight all the libraries which are impacted, right? But there is a long list of infected library, right? But which library to pick first, these tool won't tell you, right? So again, developer has no clue which library to pick first. Is there any order that developer or security engineer can follow so that he start fixing library one by one, right? So these are the two problems which analyze step will try to solve.
Excellent. Well, that's
Yeah.
a good setup. Thank you, Hemant. I
Yeah.
appreciate that. That was a good setup. We'll obviously going to talk about the solution next, but I think it's time to check in with our audience again for poll question number 2. Question this time is, what should matter most when prioritizing CVEs? So let's bring up that second poll. So here are your choices: severity score, actively exploited vulnerabilities, library usage and code, upgrade impact or effort, or the age of the CVE. So we'll wait a few seconds for you to cast your vote. We thank you again for your feedback. Again, we will share these with you in our follow-up. Also, it's time to remind you, thank you for answering our questions. It's time to remind you, you can ask questions of us by using the Q&A button in the bottom of the bottom toolbar there. We are taking questions that we'll get to at the end for our live Q&A session. So please don't hesitate to input them whenever they come to mind. All right, back to you, Hemant.
Yeah, thanks, Mike. Okay. So I have talked about the problems which analyze will solve. Now let's look at the solution. So solution is, if we build AI-enabled scoring algorithm, so it should be pluggable algorithm, so which will assign score to each infected library, right? So it will run on each library and try to give a score based upon various parameters associated with each CVs, right? So those parameters could be CV age, it could be CV severities like high, mid, low, or it could be what is the dependency of that library to our application, or it could be EOL status, right? So there are various parameters we can consider while calculating the score. So once we assign score to each library, we will have a sorted list. As you can see, so I have given an example that there are two libraries which are having CVs, but this algorithm, which is AI-enabled algorithm, has assigned a score. If you look at the score column, right, second last column, so this algorithm has given score of 83, and also instead of giving a multiple version to upgrade, right? So it has given only one single focused version, right? Now there is a clarity. Whoever is trying to fix the TV, it knows which version to upgrade, right? And there is a priority. So this is the analyze part. Now we look at the third step, which is AI migration guide. Again, I will talk about the problem which AI migration guide will try to solve. Then we will look at the solution. So as you know, any enterprise application consists of multiple teams, multiple pods. So these teams working on different set of services. But if you look at the dependency of these services, there is most of the time there is a overlapping between common libraries. Like as shown in this diagram, so the team one owning the service one and team two owning the service two, but there is a overlap between the libraries. The middle one, the red one, these are the overlapping libraries, but these are having some vulnerability with it, right? These are infected with CVs. So the problem is each team will work on isolation, try to fix these CVs at different point in time, right? Depending upon their priority. So probably team one will try to fix the CVs related to their service. This month, the other team will try to fix similar type of CVs on same library in different time, right? So as you can see, there is no common knowledge between them. So whatever the effort team one has put in to fix the CV, the same effort team two has to put in, right? There is no knowledge sharing. So as you can see, there is a duplicate effort, which is a problematic. Now, how we can fix this is by having a migration guide. So the way we can generate a migration guide is by having a multi-agent system. As you can see, there are three agents. The first agent will try to search the internet to fetch relevant information. As we already know which library needs to upgrade and to which version, so the first step is easy, that it will fetch the relevant information from the internet. Then the second agent will try to summarize the changes which is required to upgrade the library, right? And the third agent will understand the raw migration guide and will come up with a standard migration guide, right? At the end, we have a standard migration guide for each library. So now, as you can see, we have a standard migration guide for each library, which other team can refer to, which will eventually reduce the time fixing the CV. Then the third step is fixing the code, right? As I mentioned earlier, whenever we upgrade the library, there is a application code change. And the problem is currently it is a manual, right? There is a hit and trial loop, which takes time. So instead of that, what we will do, we will again introduce a agentic system where there are multiple agents. So very first step, what we will do, we will put all of our source code into the vector database. Like if you look at the image, so there is a one agent having two database, right? One of the database is to store all the source code in a vector database. The other one is standard migration guide. That agent will refer to that standard migration guide to filter out those source code files which require a change, right? So once it able to filter out those files, then it start fixing those files based upon whatever written in the migration guide, right? So once the changes has been done, it will forward these changes to next set of agents. So these set of agent will try to build the application. If there is a failure, another agent will try to fix whatever the build failure are there, right? So this loop continue, and eventually they will able to fix the code at the end. So whatever the changes they have, the agentic system has made, they will push those changes to our source control software like Git, and it will generate a PR review, right? So this is the place where human can review the changes made by AI. So this completes the whole pipeline. Just to summarize what we have explained. So at very first thing that we cannot ignore the CV, especially the critical one and the age one, because it is going to affect your business. And definitely AI and streamlined process can accelerate the whole process. And these are the steps, 5 steps. The first one is scan, which will tell you if application is infected or not. Then analyze step. It will give you a prioritized list of library. Then there is a AI migration guide, which we can follow or AI can follow to fix the changes. Then there is a step to fix the code, and the third one is PR review. So that's conclude our talk.
Yeah, that was
So
great.
Mike,
Thank you very much, Evan. I appreciate that. It was great information about how AI can be used for vulnerability management and kind of clear some of these CVEs that are making everybody's life difficult. So now it's time to hear from our audience. And so if you have a question, please type it into the Q&A window that you'll find the button there at the bottom of the toolbar, bottom toolbar there. And we will wait for some to come in. But I have a question actually, Hemant. So how do you keep CV volume in control once you've reduced the volume to an acceptable level? So I've gotten to a good state. How do I keep it that way?
yeah, that's nice question, Mike. So you're saying once we able to reduce the CV from bulk count to minimum level, right? So now how to keep it under control, right? As we know, every week new CV is coming in, especially in popular library. So to solve this, we need to have a continuous process, not a one-time cleanup, right? So whatever the process I have explained, so we need to integrate that process into our CGCI pipeline, right? So when there is a say commit into that source code, so this pipeline will get triggered and it will inform us if there is any CV or not, right? So now we can fail the pipeline, or we can have a threshold number of CVs. If it crosses that threshold number, then it can fail, right? So then we can also utilize all the analyze report to prioritize how to fix the CVs. So that's yeah.
Okay, cool, excellent. Okay, here's one we got. Someone's asking, so how should teams validate CVE fixes, framework upgrades, version bumps? These are the three things, the specific things they're asking about. CVE fixes,
Yeah.
framework upgrades, and version bumps. And what parts of testing can AI safely automate?
Okay. So whatever the library upgradation we have done, right? We have to treat those changes similar to we treat regular code changes, right? So, so whatever the process I have explained, right? The AI will automatically try to build the application, right? If there is a failure, it will try to fix it, and it also try to run the unit test cases. Like if the application has unit test cases, the AI will try to run it. So I feel having a unit test cases in your application is must. I would say we should have a 80% coverage of those unit test cases. Once we able to pass the build process, unit test cases, then other test cases like say integration test cases, regression test cases, smoke test cases, we have to run those test pipeline as well, just to make sure whatever the changes the AI has done, it is working as expected, right? We have not break our application.
All right, excellent. Here's a question for you, Aniket. So, does Talentica have a product built around the use of AI to resolve CVEs? And is it available for trial by people?
Wow. Yeah. So yeah, great question. So yeah, whatever Hemant was talking about, right? So these were the techniques and patterns that we learned, right, along the way. And yeah, we do have a product that we have an offering to help product teams accelerate making their products CV free. So currently, the product is being used by one or two customers at Talentica. Um, what we are doing now is we are investing in further in the platform. We are getting more languages, more frameworks, supporting them. So if you have a specific language and framework, right, like Node or Python, right, we can talk in detail. Maybe not right now, but we'll share something back to you and take it up from there.
Okay, great. So folks should reach out if they're interested in that. I think that's all we've got in here now, guys. So I think we'll wrap it up. Thank you very much for attending today's webinar, Transform Vulnerability Management with AI. I want to say a big thank you to Aniket, Shaligram, and Hemant Sachdeva for their sharing their expertise, and to all of you for joining us today. So as a follow-up, we want to remind you, you will receive the slides as well as a replay link directly into your inbox that you use to register, along with the poll results. We'll share those with you as well. So
Mike,
we'll
question.
also include some information about our AI-driven vulnerability management tool that was just mentioned. And so if you'd like to reach out, we can discuss applying AI to your security needs and your organization. So thanks again for being with us, and we look forward to seeing everyone the next time in our next session. Thanks, great. Have a great day.
Thanks, everyone.